Miss Sofio. Here's my pi project. A Journey to the Center of the Earth and Pi. A PowerPoint presentation by James Watt. In 1864, a science fiction author named Jules Verne wrote a great novel about traveling to the center of the Earth. Well, I thought to myself, how far did he really need to travel? By knowing and using the famous letter pi, we can find out. In order to calculate the journey to the center of the Earth, you can't just dig a hole and measure it. We are going to do it through math. The first thing we need is the circumference. In the year 200 BC, a genius Greek mathematician calculates the circumference of the Earth. His name was Eratosthenes. He was also a geographer, poet, astronomer, and a music theorist. In order to calculate the circumference of the Earth, he put two sticks into the ground at two different places 800 kilometers apart. He realized that there was a 7-degree difference in the shadow during midday. He eventually calculated the circumference using what we do now in 5th grade, ratios. Here's the ratio that he used. This is really cool that a mathematician discovered this almost 2,500 years ago, but we don't really need to get into that. Finding the circumference of the Earth was challenging enough because at that point, people still thought the Earth was flat. We have got the circumference of the circle, but I'm going to explain the relationship between the circumference and the diameter. That is pi. Pi explained. First of all, in order to use pi to find the radius of the Earth, you need to understand what it really is. The circumference is the distance around the circle, see in blue. The diameter is the distance across a circle, see in red. Every circle in the universe has the ratio of its circumference to its diameter. Soccer ball, softball, even my gum. That's the circumference, that's the diameter. The circumference over the diameter is equal to pi. Even this coin, this little dollar coin. Oops, sorry. You're probably glad that I'm not doing that in your classroom. Here's the fraction equal to 3.142. That is where pi would stand on a number line. Here's the calculation of the radius of the Earth. First, you have in blue the circumference, in red the radius. Here are my workings out of the radius of the Earth. You have the equation pi equals 40,074 kilometers. You have to divided by the diameter. Cross multiply that and you get pi d equals 40,074 kilometers. Where pi equals 3.14, you sub that into the equation and you get d equals 40,074 kilometers divided by 3.142. So the diameter ends up equaling 12,754.3 kilometers. The radius is the diameter divided by 2. So it would be 12,754.3 divided by 2, and the radius would end up being 6,377.1 kilometers, approximately. Conclusion. First of all, it is a long way to the center of the Earth. It's 6,331 kilometers. No one can really dig that. Another one is pi is the ratio of not just the Earth's circumference to its diameter, but every circular shape, big and small. In 200 BC, there were some amazing mathematicians. I mean, it's really cool that they found that out 2,500 years ago. We do that in 6th grade now. Thank you, Miss Sofio. I hope to see you soon.